All right, so let's start talking about. Let's look at the syllabus first, and then we'll talk about all these things you're cordially required to attend. All right, so it's pretty much a normal Littman class. 60% of your grade is assignments and pop quizzes. Midterm is 20% of your grade. Final is 20% of your grade. I have my usual policy. If you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with whatever you get on the final exam. Questions on any of that? Pretty straightforward grading. You're going to have lots and lots and lots of assignments. You'll spend lots and lots and lots of time on them, and that's worth 60% of your grade. Those are the reps. Remember, programming is like a sport. So you're going to spend time doing your homework, but you will have the self-evaluation to turn in where you'll tell me what your experience was like on it, so I can give you partial credit in the event that you aren't able to show me a completely working program and that kind of stuff. All right. The idea is that you show me you put in the effort and the time in your homework, you're going to get a disproportionately high grade on homework compared to what you've actually produced in terms of, solution, right? That doesn't mean you can just turn in a, blank assignment that, with some funny thing on it and expect to get a high grade. But if you convinced me that you spent a lot of time on this, actually working on it and learned some stuff, then you're going to get a grade way better than a 0. All right, questions about any of that normal housekeeping stuff? All right, so now let's look at our required events. First of all the Bible homework for the entire semester. That's interesting. Why is it copied twice? Yeah, it's like a different class. Yeah. Let's delete some of that stuff. I'm probably deleting from the other class. Just later. See, Blackboard always works flawlessly. It's a truth. All right. If you want, hit on the third button down on those lights over there. Hit the third button down. Right here? Yeah. I think that should take the glare off this somewhat. Is that better? Or is it pretty much the same? No. I don't think so. Yeah. In fact, I don't even know why we have them up. They, I think, in theory, will work with the instructor station up here that doesn't work. so big. Yeah. Well, we've AV won't come in here because we have a little bit of a historically insignificant setup that they won't touch. So I think between over next summer, I think is when it's going to happen. We'll end up getting that replaced with a regular instructor station. I don't know. But this is a pretty good sized TV. You can see this from back there, right? But there's plenty of room here in the front. Lots and lots of room, right there. Anybody wants to scoot forward, it's fine. So all the Bible homework for the entire semester is up, 14 total assignments. They are staggered. They're due every Sunday at midnight, just like last semester. We're going through the book of Matthew this semester, and each week is 2 chapters, but it's the same response, a couple paragraphs, blah, blah, blah. Yeah?
How do you select where we read from?
I don't. Mr. Gonzales does. Okay. I don't know. I usually try to pick something New Testament, and I don't know. It's just kind of what the Spirit drives me to pick at the beginning of the semester, and hopefully it's different from the last semester and distanced enough over the 4 years that you're in school that you don't have the same stuff you read. The ultimate goal is that you are required to do this, and then that turns into kind of a regular Bible reading type thing that you might do on your own when you're not earning points for it. You know, from my perspective, I don't care. I give so many assignments that it just kind of washes in there, and it works out okay. But, you know, choose your poison. So 14 total assignments. Feel free to do them all up front if you want. I'd really encourage you to do them on a weekly basis to get used to that, you know, constant reading thing in the Bible. But hey, if you want to just knock them out, or you don't trust yourself to remember to do them and get them turned in by each Sunday, hey, have at it. And then, you know, you can knock them all out this week, and then you can do a normal, regular Bible thing on your own after that, just because you want to. Also, plenty of room in the front row of chapel. For those of you who go to chapel, we have our front row club, where today I had one other person up there with me. But Pastor Smith gives extra credit if you're in the front row, and God sweeps through there first. Hey, look, I don't make the rules. This is just how it goes down, is what I'm saying. Okay, so that is the Bible homework. It's up for the entire semester, so you can tackle that. But they are already have the due dates, and it's every Sunday by midnight. All right. Next, required tech talks. All the dates for these are up. So the Grace Group this semester is hosting a series of tech talks, which are going to be from 6 p.m. to 8 p.m. 8 p.m. at the latest. They'll probably finish earlier than that. And what we do is we're bringing in guest speakers in the tech industry from off campus who are coming in, and kind of what we've told them to do is pretend like they're talking to their 20-year-old self. What would they want to tell their 20-year-old self about the tech industry? What it's like to work in the industry? What are the different jobs that are available out there? The guy at the first tech talk is he's the head of software engineering at a company called SkyTech, where we've had some students intern. So those are internship opportunities for students, and he can kind of talk about his journey and how he started off in the mailroom and now is basically running a company making a couple of dollars a year, that kind of stuff. But the whole idea of these tech talks is to expose technology students, not just computer science, but from our perspective, mostly computer science students, to what industry is really like, and kind of broaden your horizons on the types of jobs that are available out there. Because, when you first go into CS, you think, oh, well, I'm going to write video games. And then kind of anything beyond that might be a little bit outside of scope, or maybe you write business applications. But there's a whole world of stuff out there where business applications can mean so many different things, where the companies you might work for are companies you wouldn't even think have computer science jobs, yet a huge majority of their jobs are computer science jobs. Banks, insurance companies, to name a few. And I don't remember which week another speaker is, but he works for a company that if you saw me put up some internship opportunities, did that guy get back to you? The .NET job?
From Optimal.
Yeah.
Yeah.
Okay. So yeah, there's a guy from Optimal Blue who is going to talk, and that company, what they do is they have software engineers who write the software that marries consumer people looking for mortgages, for loans, to wholesale loans. So when you go into your local bank, Bob's Bank, and you say, I need a loan for a house, Bob's Bank is going to give you a loan at a retail price, whatever the interest rate is, 4%, 5%. And then they're going to go and find somebody to actually loan the money at a lower percent, so they make their couple of percent in the middle. So this place writes software that allows them to efficiently find the best loan for those local banks, let's say, and then the bank pays them a quarterly subscription fee so that they always kind of get the best bang for their buck. When Bob's Bank sells you a loan, they're going to get the best, the lowest interest loan on the back end, so they can make the most profit off of you, because they're only going to keep your loan for 5 seconds. They sell it to you, then immediately flip it to them, take their little cut in the middle, and they're done. So interesting stuff like that. So these events are 9/4, so that's next week is the first one. And these are over in, it's called the Collaboratorium, over in the new business building right outside the new CS Makerspace, kind of the big area on the first floor of that. So 9/4, 9/18, 10/2, 10/16, 10/30, 11/11, 11/26. Those are the 7 events. So mark your calendars for those, 6 to 8 p.m. Strongly require you to show up to those. If for one reason or another you aren't able to make them, there is an alternative assignment. So if you're unable to attend the event, you should research the speaker. I'll let you know the speaker the week before the event. And write a 4-page paper answering the following questions. Who is the speaker? What does the company do? What kinds of tech-related jobs are available at the company? What skills must a tech-related employee possess at the company to get a job? And would you consider working for that company? Why or why not? Path of least resistance would be to show up to the thing, get some free food, listen to the speaker. Because if you listen to the speaker, you can just write a few paragraphs, just like the Bible homework, about what you heard. Make sense? All right. So hate me if you want, but show up to those. I'm not going to lose sleep over it. So, and I'll be at all of them. Then we have the required hackathons. 2 of them this time. First one is our Lady Ada hackathon. That's our internal one. That's going to be on October 5th from 8 a.m. to 8 p.m. Our normal 12-hour one. That's a Saturday. So you either take a picture with Mr. Gonzales if you're at the hackathon, or you can do the penalty assignment that will be announced the week before that. You want to show up to the hackathon. So ask for work off now and all that jazz. If for some reason you absolutely just cannot attend it, there'll be that alternative assignment that will not be fun. And that's worth 3 homework assignments. Then we have a thing this year that's new called the Batterman Battle Hack. So the history behind this is we have typically traveled around the country taking students to these hackathons around the country. We have a hackathon club, and we go to some of these different hackathons, which are like programming competitions. And traditional hackathons are 24-hour events. We used to do this one called Battle Hack that was put on by Braintree, which was a PayPal company. And Battle Hack was really cool. If you've seen on Slack, do I have my Slack channel open here? So this is us here. Let me find something in general where I've posted recently. Yeah, so if you've seen this picture, that is me at Battle Hack in Raleigh, North Carolina. So those are the trophies. They're actually battle axes, were the trophies for that thing. The way Battle Hack worked is they had 14 hackathons per year at cities around the world. And 4 of them were in the United States. We went to New York City, Raleigh, North Carolina, Chicago, and Los Angeles. Raleigh was a 14-hour road trip that we did caravan style. Well, I didn't, I flew. But the students did caravan style. And I actually probably can find the video somewhere. Josh Curcio, who now works up at Acuity, he was running one of the groups. And I get this text from him like 3 in the morning. I guess the car that was in front of them, not related to our group, the guy fell asleep at the wheel or something like that, went off the road and like jumped the ditch and flew into a tree. Car stuck in the tree. Okay. Well, so they pulled over, they ran up there to make sure. I mean, basically they thought this guy's gone, right? Guy was fine. He was still listening to his music up in the tree. So they called the police and stuff. So I get this video chat from Curcio, like, with police and all the stuff behind him. He said, it's like, yeah, he tells me the story, like, everything's okay, we're heading to Raleigh. I guess it's still another 5 hours outside of Raleigh, but apparently the guy was upset that they called the police. I'm guessing no license, no insurance, possibly transporting something. Who knows? But funny little backstory. But anyways, and the good story with that Raleigh one is we only got so much support from the university for money to get us there, so we did we crowdfunded it, and PayPal actually, we had like 30 seconds left before our thing ended, and we weren't going to make our goal, and then PayPal finished meeting it, so gave us the rest of the money, and they did this whole story on us while we were there. But in any case, the battle hacks were kind of like what I would call like a professional hackathon, what a hackathon done right looks like. Really good food. They had vendors from like famous places in industry that were there, giving away free stuff and giving prizes for the best use of their APIs and that kind of stuff. So they were really good experiences. Well, when Braintree, when PayPal spun off Braintree, where it's no longer a PayPal company, Braintree still exists. They're a payment processing company, but they're not a PayPal company anymore. They canceled the battle hacks. But the idea for the battle hacks is there was 14 hackathons. The winner of each of the 14 hackathons came together for the world championships at PayPal headquarters. Winner takes all for $100,000. All right, so we're going to try to have our own. This is going to be the first annual battle hack here on campus. And we're doing this along the same timeline as Startup Wisconsin Week. There's a subset of that called Startup Milwaukee. So we're going to hopefully have a bunch of sponsors, some good prizes, not $100,000, I'm guessing, but there will be some cash prizes as well as like good tech prizes. This one is a traditional 24-hour hackathon. It's from 8 p.m. on Friday the 8th. to 8 p.m. on Saturday, the 9th of November. And again, that is over in the new business building in the Collaboratorium. All right, so we'll talk more about that as we get closer to that, but save the dates. Again, if you absolutely can't make it, and you are allowed to sleep, by the way. Traditionally, hackathons like that have, it's 24 hours, but there's usually like a quiet room, a sleep room, that they set up some air mattresses in and stuff like that. And, some people go the whole 24 hours and don't sleep, but it's not uncommon for people to sleep. And we'll have good food and drinks and all that jazz there. And hopefully some good prizes and some good sponsors. Sargento is going to be one of our sponsors, so at the very least there'll be cheese. We're hoping to get Acuity as a sponsor and so on and so forth. One of the interesting tech talks, to kind of bounce back to that for a second, and we're doing these the tech talks are roughly every 2 weeks. I think it's the third one, I can confirm and tell you, but we're going to have general managers and the senior VP from Acuity Insurance up in Sheboygan come down, and they tend to hire some of our best students each year. Typically, whoever our outstanding senior is, 9 times out of 10, they're working for Acuity. And Acuity is even though they're an insurance company, they have like a Ferris wheel inside the building. Like rock climbing is like the Google of the Midwest. It's kind of cool. So we're going to have them come down. Their high ups are going to come down and do the tech talk one of the weeks. And then 2 weeks later, we've invited back computer science alum from the program who currently work at Acuity to do a roundtable panel where we can ask them questions. You can ask them questions to tell what industry is like from a former Concordia computer science student's perspective. So those are, again, good things to show up to, but you should show up to all of them or do the alternative assignment, but whatever. All right, so in this battle hack thing, it will count as 5 assignments, and the penalty assignment will scale appropriately. So again, I do realize that these are a lot of time commitments. Trust me when I say I've been doing this for a few minutes, And students won't show up to stuff unless you require them to show up to stuff. This will make your life better with your degree. This will help you get internships with some of these places. You can turn in resumes to these people. If I don't force you to do it, you're not going to do it. It's the punchline. So hate me if you want. Give me a bad review if you want. I don't care. I have tenure. So, it is what it is, but it's these are important events, and I think you will learn a lot from them. All right, questions about any of those required events? So mark the dates down, ask for work off, swap schedules, whatever. A funny side note from these is, because on here it's, you're supposed to take a picture with Mr. Gonzales, and most of you in here know who Mr. Gonzales is, right? Okay, if this is you just transferred in. Mr. Gonzales is a doll. Okay, he's an elf on the shelf doll that has traveled all around the world, my wife and I. Well, this semester, we have, and actually the funny thing is one of the students who is in this class is the one who I'm about to reference, but I won't say their name, so they'll get a kick out of this when they watch the video. But Concordia Ann Arbor has 0 computer science faculty right now. So all of their students are in our classes doing it online. And so one of their students who already had access to Blackboard emailed me yesterday wondering how we were going to handle these hackathons related to Ann Arbor being a 7-hour drive, right? So he says in this email that, I see that we have to attend this hackathon, presumably with Professor Gonzales. And I, of course, replied back and said it's Reverend Dr. Gonzales. So I just got a kick out of that. It's pretty funny. That's the point where the joke is kind of gone too far, but it's great. So we're gonna get a nice picture up of Mr. Gonzales as a visiting professor or something like that. We've actually also talked about putting paperwork through and actually see if we can get him health insurance. Yeah, how far does the joke go type thing? That's what I mean. Yeah, at some point he shows up on Concordia's website for arts and science faculty, and not as a joke, somehow the paperwork went through where he was actually scooped up as in an official employee. He has a phone number. He's got meal plans. He's assigned to somebody's roommate in the dorms. He's just sitting there, just the guy won't stop staring at me. All right. Yeah, so I thought that was pretty funny. Okay, so any questions about any of that stuff? So make sure you, as soon as possible, mark those dates down in your calendar and ask for work off or whatever, blah, blah, blah. We want to, and there will be food at all those things. Hackathons will have good food. The other things will have more refreshments. Yeah, I'm guessing cookies, granola bars, maybe pizza at some of them. We have 7 of your classmates. Some of them are in this class, but other ones are in other classes. Each have ownership of one of those tech talks. So if the food sucks, it's their fault. Okay, but they do have a $100 budget for food for each of them. So they can do with that $100 whatever they want. Get a couple of packs of gum and pocket the rest. Whatever you want. It's your money to do what you want with. Okay. So I think that is everything for the class. Any questions I need to answer about anything before we just start doing things? We're good? Okay. Well, actually, one more thing I'll throw out there, and I'll put it up with the self-assessment thing. We really want to encourage folks to use some of the new spaces we have on campus. This lounge that we have over here. We are going to have study tables set up in there. So if you want to, especially in this class, just like last semester, It will greatly benefit you to get into study groups. We're going to hopefully have some official study groups set up. If you are one of the people who typically runs those study groups, one of the stronger, more experienced students, let's say, let me know, because we want to get you in touch with the Learning Resource Center, because they'll actually pay you to run the study groups. Okay? So if that's of interest, let me know and I can connect you with the right person. Similarly, if you are somebody who is interested in helping out with the department sometimes, whether it's helping us on some external VR demo things or keeping the soda machine stocked and cleaning up around the department or doing other side projects, even if it's not a regularly scheduled shift or something like that, we do have hours where we can pay students. So if you are interested, let me know and I can get you on our books so that when I do ask you to help out with something and you agree and you spend an hour doing it, we can pay you for that hour. Okay? Otherwise, if you're not on the books, there's nothing I can do about it. I'm not gonna pay you out of my pocket, but which is fine. But I'd rather not use my money. I'd rather use the school's money. If you're helping the university do something. If you're like cleaning up my garage, we're not going to use the university's money. Mr. Gonzales pays for all that. All right. So in any case, in an effort to use the space here as well as keep active the new space over in the business building, we have a maker space over there right off the collaboratorium. I'll be giving extra credit if you submit evidence that you worked on a homework assignment in one of those two spaces. So if you get together your study group, meet in one of those spaces so that it looks like it's alive, people are using the stuff, things like that, and I'll kick in a little percentage. I'm figuring out what kind of percentage I can give you that is enough of an enticement that you'll do it, but not so much of an enticement that it like horribly skews grades. I want to reward you, but no more than like half a letter grade type thing where you just look, I failed every assignment, but I did them all in the lounge, and I got a B-. I didn't even take either exam. All right, so look forward to that as well. Maybe make some of your study plans to come and use these spaces. Like I said, we have Netflix on the TV, free soda in here, yada, yada, yada. Okay, textbook for the class. Just like last semester, we're going to be using a Zybook. The instructions for getting to it are up here under required textbook. So go to Zybooks, you put in this code CUWCS250 Littman Fall 2019, click subscribe and give them money, and they will give you the book. The book looks like this, very similar to what you had last semester. You'll notice that some of these things do overlap, but we are converting between Python and Java this semester. So we will probably go through the first several chapters here in the first 8 weeks, let's say, the first many chapters. And then we'll start differentiating ourselves. So what we're going to do is we're going to be spending roughly the first half of the semester expanding our computer programming skills. So we started off as beginners last semester and we ended with as intermediates. We're going to go from intermediate to advanced minus, let's say, in here. And then the second 8 weeks, we will be continuing our practice, but in the context of writing Android applications. Okay, so we're going to be doing straight Java the first 8 weeks, and then Android-based learning how to write mobile apps the second 8 weeks. And if you take it seriously enough, you can start putting apps on the App Store and make money off of it or something like that. And cool enough stuff. Okay. But I'd almost look at the Android stuff. We're not going to necessarily teach you how to like make these like amazingly beautiful interfaces and stuff like that. If you want to go and take that to the next level, go ahead. We're going to have very simple interfaces, work with graphical user interface stuff and event-driven programming. So it'll be enough to be dangerous, but it's almost like when you give a dog medicine, you hide it in some food, right? So we're going to be teaching you programming concepts. It just happens to be hidden inside of writing Android stuff, so it'll kind of feel fun. or feel frustrated because Android updates about once or twice every 15 seconds, and that just breaks everything, which is good. Yeah. I'm not even kidding either. It's so good. Okay. Just your class?
Yes.
All right.
Yeah.
I assume this is not flickered yet? All right. Yep. So it was my adapter. I thought that was my good adapter I brought yesterday. Maybe it got wet in Iceland. Remind me, how do human beings solve problems? All right, so memory, asking questions, and repetition. What's a programming language? What's the job of a programming language? Anybody wants to say, just go, yeah.
Just like translate like human language into like computer language that understands to run applications, essentially.
You always throw the essentially onto the end of it. That's,
Well, it's not a good
yeah. Right. That's, I mean, that's not horribly wrong. It's just not right.
To force a computer to use as close as what we can to our language that then gets converted down to binary.
Okay. Yeah, between the two of you, it's like a C minus. So nailed it. No, I mean it was fine. So the job of a programming language is to allow us to solve problems in a similar way to how we already solve problems. All right, because remember, human beings are professional problem solvers, right? Okay, we are great at problem solving. In fact, why does that make programming hard? Why is programming hard? Help me finish that slide out again.
We don't always know like how to translate that into instructions, into simple instructions for a computer.
Okay, we are so good at solving problems that we have trouble articulating how we solve them. We're so great at it. You know, the example I used last semester is you're walking down the hall, not bumping into any walls. In fact, you can't even pay enough attention because you're texting on your phone. You're bobbing and weaving out of people. You're not falling over. Walking is really, really, really complex. You're having to fire all these different muscles in order to accomplish walking. And if I told you to unambiguously articulate to me every single detail that it takes to walk, you couldn't do it. To you, it feels like, oh, that's way too complex. But evidence suggests that it's so trivial you can text while doing it. Human beings are really good at solving problems. So a weakness of ours is that we suck at articulating how we solve problems because we just walk. We just figured it out. You know, replace walking with a million other things that we just kind of figured out how to do, right? You know, like hold our head up, right? You know, when you're a newborn, you know, the newborns can't hold their head up, right? And eventually, as your muscles develop, at some point you have to figure out how to, at all times, kind of fire the muscles in your neck and shoulders to keep yourself upright. You know, then we get the knots in our shoulders and stuff like that. But you don't think about doing that, right? You're not sitting in class right now and says, okay, I can't let my head drop. You just do it, all right? So programming's hard because we need to unambiguously articulate every tiny little step to the computer. And we're so good at solving problems that we don't often do that. All right? Job of the programming language, allow us to solve problems in a way similar to how we already solve it. This is not an equal relationship between us and the computer. Okay? We aren't going to meet the computer halfway. It's got to be 99% the human way, and we'll kind of do the zeros and ones thing a little bit, right? So we need high-level languages that allow us to write English-like sentences, English-like words that ultimately will solve computer problems. They get translated into other things. So let's just call it high-level languages. Humans write English-like words. And then what translates those English-like words into computer speak? There's two options. Go ahead.
Interpreters.
Okay. Or interpreters are what we used last semester, right? Python was an interpreted language, so we always ran everything through the Python interpreter. Or compilers. I was putting quotes here because technically interpreters don't actually convert. They just kind of in real and then like the Python interpreter was written in a high-level language that was compiled for the machine code. So what ended up happening is when you ran your Python program, Python, it interpreted your Python instructions in real time and just made them run on the computer because the Python interpreter was the guy that already knew how to talk to the CPU. In this class, we're going to be dealing with a compiled language, Java. And compiled languages convert high-level code to low-level code. Now, the reality is that from a programmer's perspective, both of these effectively do that. They are taking our high-level English-like language that human beings can comfortably write stuff in, and they are converting it into something that ultimately the CPU can understand. Remind me, what is the CPU? Go ahead.
The central processing unit.
All right, that's what it stands for. What does it actually do? It just runs stuff. That's probably better than your C- from before. No, I mean, I wouldn't go that far. Just better than the. It's like, well, there's nothing in between. Well, I mean, you're gonna have to rely on Roundup. What's the CPU? What does it do? Go ahead.
Kind of like the brain of the computer that tells the interpreter and compiler what to do.
Okay. Kind of other way around. The interpreter and compiler spit out low-level language. So here we can do something like this. We can say runs low-level language. Usually this is something like assembly code. And if you remember from last semester, we kind of referred to the CPU as a collection of magic tricks. Remember that guy? Okay, so our CPUs know how to do a whole bunch of little tiny things. Probably in class I did something like this. I said, everybody put your hand up, move your thumb like that, right? Okay, we're all impressed we can do that, right? You know, we can go like that too. But those little tiny movements, when put together in certain things, can accomplish real tasks, right? I couldn't grab my soda here without, do you guys see these quench cups? Cafeteria is selling these now. It's great. At least for faculty, it's great. You guys probably have meal plans, but for years, faculty have been like stealing coffee and soda from the cafeteria. Well, now we can buy this cup, and I got the premium one, and it gets me unlimited drink stuff from the caf, and also I could take it up to the Starbucks and get like Tivana and normal like the Pikes Peak coffee and stuff like that. Like $60 for the semester. It's not. Yeah, for unlimited drinks. For unlimited drinks. I have to find out though if I can take it down to the Nest and get drinks down there, because sometimes the BBC closes at like 3 p.m. or something like that. And then the Nest is open, and I'm assuming till late, because they have Tivana and Starbucks stuff down there. I might just walk down there and just pretend like I'm allowed to. All right, so CPU is a collection of magic tricks where each trick performs some very small task. When a bunch of tasks are performed in a certain order, a real solution to a problem occurs. Do I know how to spell occurs? Yeah, there's got to be that many C's in there. All right. All right. So, ultimately, when they make our CPUs, and we talk about this in the 325 class in a lot more detail, the computer organization class, but you know, each year when new CPUs come out, you know, so like this year where we're on our 8th gen Core i7 processors, right? Next one will be the 9th gen Core i7 processors. So what's the difference between the 8th gen and the 9th gen and the 6th gen and the 7th gen? Besides price and, well, you got two laptops. One of them has the 8th gen, the other one has the 7th gen. 8 must be better than 7. And then what they always say, oh, it's up to 40% faster than last year's, blah, blah, blah. What does that mean? What does it mean to be 40% faster? How many of you have ever bought a laptop or bought a machine and you went to the next level up for a processor because it said it was 40% faster? Who wants to admit to it? I feel like I'm about to walk into the shredder. All right. So, what's the difference between the 8th gen and the 7th gen processors? Go ahead.
Basically, they make the circuitry like a lot more complex, so it can run faster through that way.
Okay. So a lot of times, you're saying something with the circuitry. So the enemy in computer architecture is heat. All right. So things get too hot, bad things happen. And along with that, we also have an interference issue. So so like the new processors that just came out are 7 nanometer processors. What does 7 nanometer mean? I mean, it just sounds better than 8 nanometer. Because nanometers, right? What does it mean for it to be a 7 nanometer processor? Isn't it funny how, I mean, you can go like to Best Buy and they have that on the tag, right? Okay, I'm sitting in front of a room of a bunch of computer scientists and you guys would just make blind guesses at that, right? Okay, you think grandma who's walking into Best Buy cares about 7 nanometer processors? No. Okay, so 7 nanometer has to do with the technology they're using. When they print those boards, when they print the processors, the dies, it's how close they can get the wires to each other. So we need really, really, really good technology in order to get wires as close to each other as possible. I mean, at that point, you're like printing at the microscopic level where they need to be so close to each other to conduct electricity, but not so close to each other that they start interfering with each other. And the better technology we get, the closer we can get them to each other without them interfering with each other. And at some point, we're going to run out of the kind of the usefulness of silicon, which is what our modern material that processors are kind of made out of. All right, so our processors keep, as we get more and more the smaller nanometer stuff, because our processors, how many of you have built a computer in the last couple of years? Okay, are the processors right now any larger or smaller than the processors from 3 years ago? Same physical size? What sometimes changes? Sometimes you have to switch to a different socket because the number of pins changes, right? You know, it used to be you looked at the bottom of a processor and it had, I mean, you could like almost put a fingernail between the pins. You know, now the thing is, I mean, it's just a wall of pins, right? There's no space and you bend one of those things and it's like all of a sudden you're like, okay, I need the right tool to bend this back or I've ruined this processor, right? That's why they have the zero insertion slot. But now the ones, they're pinless, right? So they just rely on the metal-to-metal contact because it was almost impossible to insert a processor with 4 zillion pins in the bottom without bending something. Okay, but those are the outputs of our programs, outputs of our processor. Okay. Now, when we talk about, so those processors have the same physical space on them as they did last year and the year before and the year before that, yada, yada, yada. Those processors aren't physically any different in size. But the smaller that nanometer number gets, along with a couple of other things, the more extra space we have on that same amount of real estate, right? And the more extra space we have, provided that we can somehow accommodate the extra heat, means we can build some extra magic tricks or update old magic tricks. That makes sense? So when they say, hey, this processor is 40%, up to 40% faster than last year's processor, that's not across the board. That might be in a very, very, very specific application. Maybe it's a new magic trick or collection of magic tricks they added to the processor because they have a little bit more room. Maybe it's an update to an old magic trick where they say, hey, there's a more efficient way for us to solve this. Something like that. So in order to realize that boost in performance, you would have to be performing a very specific set of tasks. Okay? Otherwise, last year's processor's just as good. Maybe one's a little bit more or less memory or power efficient, things like that, but go ahead.
So a lot of the time when we pay for something, we're paying for like, not like I'm trying to think how to phrase it. So you're paying for the work of the inventor. So like the time they took versus the actual cost of the product.
Mm-hmm.
How much of that goes into like computer hardware, like processors, for example? Like how much are you paying for the creation, like the process versus the actual product?
Well, I mean, I think quite a bit, but that's why the newest, latest, greatest stuff is more expensive than last year's. Last year's model, they reduced the price of. So they are spreading the research and development cost across the 4 zillion processors they're selling. And they're not just selling to individuals, they're also, Apple buys, 300 million 8th gen Core i7 processors for their products. So they have them on hand to go and sell them and all that stuff. So bulk gets split across a lot of individual processors. And then on top of that, you also have to consider it's built into their margin, right? If a processor costs Intel, I would just be making something up. Let's say printing one processor after all that R&D, let's say costs Intel $10 in material and stuff like that. That's not taking into account all the research that went into that awesome solution. But now with and also the cost of all their machinery and the thing to print at 7 nanometers and all this stuff, at the end of the day, if they're able to pop processors out at $10 a pop and they're charging you $500 a pop for it, you got a pretty good margin. And that margin is having to make up the difference in bulk for the cost of all those other things. That's no different in computer hardware than anything else, right? When you go to a store and you buy a refrigerator, that you buy some stainless steel refrigerator and it's $1,500. It didn't cost them $1,500 to make that refrigerator. Otherwise, if it did, they would not be in the business of selling refrigerators. They would be out of business because they have to pay to keep the lights on and all that other stuff. So, the normal stuff. In general, I think in technology today, we have the advantage because since there is so much, there are 7 nanometer processors that are made by Intel that are in so many things that we don't even think about. That margin, that cost of research and machinery and all that stuff gets spread across a pretty big product line that we don't necessarily consider when you're buying your latest, greatest Intel-based laptop. Because there's a whole bunch of processors that can drive that laptop, but then you have processors that are driving other things that we don't even think about because they're not bragging about the Intel-based chip that's sitting inside of a dishwasher or something like that, which may not be Intel, but you get my point. When you buy a dishwasher, you're usually not buying it based on processing power. It's like, well, this dishwasher has a Core i5. And what does that mean for the rinse cycle? All right, so in any case, that's what a CPU is. And the difference between the 7th and 8th and 9th generation is going to be when they say it's a % speed up, it's going to be for specific types of tasks that they've either upgraded or had new real estate in order to create those solutions. And we're going to keep going, but we are having diminishing returns now. you're going to see far less of a performance difference between the 8th gen and the 9th gen Core i7 processor than you probably saw between the 1st gen and the 2nd gen Core i7 processor. You know, we're running out of problems and we're running out of smarter solutions to those same problems. And we're going up against a heat in a nanometer wall for constructing those chips. All these things add up to eventually it's going to be hard to make the processors much faster, but almost always today, when you buy a computer, the CPU is not the problem. Very rarely is the CPU your bottleneck. If you're buying a computer today and you're on a fixed budget, where do you spend your money first? No, not what company. The parts of your computer that you're putting together. You definitely need a processor, right? Computer's not going to work without a CPU. But so you're going to buy a CPU, you're going to buy a hard drive, you're going to buy memory, all these things. What needs to be the absolute fastest? Hard drive. Get a solid state hard drive. Not a mechanical hard drive. You can surround a mechanical hard drive with the fastest of everything else, and that machine will feel slow. Because mechanical hard drives are slow. SSDs are orders of magnitudes faster than solid state, than mechanical HDDs. So for now, if you have a laptop or you have a desktop computer, that is upgradable. So for instance, if you have a newer Mac, not upgradable. But if you have an older Mac where you can actually get to the hard drive, or you have a PC laptop, if your machine has a mechanical hard drive in it, an HDD, and you have a couple of bucks laying around, you feel like your machine is slow, get a solid state drive, replace that hard drive, and your machine will feel like 30 times faster. Shocking the difference that one part will make. You know, it's also the reason that people got confused during the transition, because most of the new machines you buy today have solid state drives in them, right? They're common now, and the prices come way down for the larger ones. But you might be at Best Buy and you see, oh, this machine has a 2 terabyte hard drive. And then for $400 more, this machine has a 512 gigabyte hard drive. How am I upgrading to less storage? Well, the difference is the 2 terabyte was a hard drive, an HDD, and the 512 gigabyte, a quarter of the space, was an SSD, which is going to be way faster. So unless you need that crazy capacity, get the SSD. Usually what you do is you get an SSD that's big enough to hold your operating system and the general core of applications you have. And then if you have like some giant pirated music collection, you put it on an external hard drive, USB hard drive, where an MP3 doesn't need to be transferred at some crazy bit rate. But don't steal your music. All right, so a CPU is this collection of magic tricks that ultimately, as a human being, we're going to write this English stuff, right? Some high-level language, and then through a collection of tools in between us, interpreters, compilers, assemblers, stuff that we don't have to deal with, but they're tools that we will use, will ultimately turn our beautiful Java or Python code into a bunch of tiny little magic tricks that the CPU understands. Looks like zeros and ones at the end of the day, because your CPU says, well, my magic trick 0001 does this. My magic trick 00010 does this. My magic trick 00011 does this. So on and so forth. They're just numeric magic tricks. All right? So that's what ultimately happens. That way, as a human being, you don't have to sit there with the 2-button keyboard just tapping out instructions. We'd suck at it anyways, and, well, we'd go insane, and we'd make a lot of mistakes. Make sense? All right, so computers ultimately have a CPU that's going to run those magic tricks. Human beings, we're not having any of that. We want a nice high-level language where we can go and write stuff and it looks like English, because programming is hard enough as it is. Why? Because we're too good at solving problems. Make sense? This is all starting to come back to you now?
Yeah.
Hey, I assume most of you spent most of the summer practicing your programming? I did tell you to do that at the end of last semester, right? How many of you listened? So, what is Java? So Java is the language we're going to be looking at this semester. It's probably the most popular. If you look at top programming languages in industry, Java's usually number one. Kind of your top 5 are going to be Java, Python, C, C++, C Sharp. Somewhere in that top 10, you're going to see Swift in there. You're going to see maybe you'd see like Node.js, Ruby on Rails, some other technologies spread in there. But, you know, bottom line is this isn't like a teaching language. This is a language where if you went up to Acuity, you're a Java programmer. You go and work in most of industry, you're going to be a Java or a C# programmer. If you're doing something more on the website or now more with like machine learning, scripting type stuff, you're probably going to be using Python. Python with like data science is kind of a new big thing. Big data, data science is kind of a Python-y type thing. But punchline is last semester you worked with a super popular language that will help you get a job. This semester you're going to be working with a super popular language that will help you get a job. These aren't made up teaching languages. Okay, way back there was a language called Pascal. Have you ever heard of the programming language called Pascal? So Pascal was a language, it was developed it was kind of written in terms of C. Remember that chart we had last semester? We talked about the hierarchy of our old languages and everything kind of came from C. Well, we had a language called Pascal that was written in terms of the C programming language, but the goal was that it would, it was made specifically for teaching, because we talked last semester how C can be a little bit dangerous for beginning programmers. Especially back then with those compilers, because you could actually crash your computer and have to restart because your program was written to overwrote some other memory. We have protections in place for that now. But we used to, so when I started in college, I wrote, my first programming class was in Pascal. And I mean, at the time, nobody professionally wrote Pascal because there was a language created specifically for teaching. Now, eventually, what happened is enough people knew Pascal that Microsoft decided, wait a minute, we got a bunch of people that know this language. We're Microsoft, we might as well have a product that lets them program in that language so that we can make money off of it. So originally it was called Fox Pro, then it was called Delphi. Used Pascal syntax. Those are all dead now, unless you're in some really old company or a company that's been around for a very long time that might have some old legacy stuff that's just still written in some of that stuff. But Microsoft doesn't release those products anymore. But in any case, we're using real languages that are used in real industry today, and you can go out and get jobs using this stuff right now. So where does Java fit in our world today? So it's a high-level language. It is strongly typed. Python was loosely typed. What's the difference between a strongly typed language and a loosely typed language?
You gotta declare your variables.
Okay. So in a loosely typed language like Python, we could just, the first time we needed a variable, we just said, this equals this. Right? Variables are name value pairs. Remember that? Okay, that's how we accomplish memory. So that's this guy back here. Remember we had this slide called the mapping. So memory is accomplished through variables. Variables. Asking questions is through conditionals, usually if statements. Repetition is accomplished through loops and functions, procedures, methods. They're all synonyms for each other. All right. So memory, basically 100% of programming languages will have facilities for these three things. Now, last semester we learned Python, and we know how to create variables in Python. We know how to ask questions in Python. We know how to accomplish repetition in Python, right? So if we learned how to do those identical things in Java, we've already mostly caught up to our knowledge of Python. There are a couple little tricks here and there, like, oh, how do I get the length of a list? Or how do I, just those extra functions that help you accomplish little tiny things. Like, what's the equivalent of range 0 to 15? How do I accomplish that in Java? But in general, if you have the syntax for declaring a variable, asking a question, and accomplishing repetition, in Java, you can directly translate your Python knowledge over to Java and start programming immediately, right? Same thing's true for any programming language. If you're working with a piece of technology that either doesn't support memory, well, it doesn't support variables, conditionals, or loops/functions, it's not a programming language. It doesn't mean it's useless. It just means it doesn't fit into the category of a programming language. All right, so Java is high level. It is a strongly typed language. And what that means is when you define a variable, you have to specifically say what kind of value that variable is built to hold. So you must specify the kind of value a variable is built to hold. And once you do that, that's the kind of value you can hold from that point forward. Yeah.
What is like the benefit of it being strongly typed?
Speed.
Speed? Okay.
Yeah. If you remember from last semester, we had kind of two interlocking things. We had interpreted languages tend to be loosely typed languages. Compiled languages tend to be strongly typed languages. Those strongly typed languages tend to be fast, relatively fast. The interpreted languages or the loosely typed languages tend to be relatively slow. Again, we say relatively because computers are really, really, really fast because, obviously the latest, greatest 7 nanometer, 8th gen Core i7, blah, 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 40% faster than last year's Ferrari. Can do stuff so fast that we wouldn't even notice. So we could probably comfortably say that 99% of applications that we would ever write will run, from a human being's perspective, the same speed on both. But every now and then you run into an application like video games or scientific research type stuff or maybe some big data stuff where the computational complexity it's having to go through to accomplish that problem is sufficient that you will notice a speed difference where you want that running directly on the processor, not through some sort of interpreter. So every now and then time complexity makes a difference. Okay. In fact, we had an example of that last semester. We looked at Euclidean algorithm last semester. We did fractions, right? Yeah. So remember we did the reducing fraction thing where we had a program that just seemed like it ran. We let it run for like 10 minutes or something. And it was not done. Remember that guy? And then we rewrote it using this stupid little 5-line algorithm called the Euclidean algorithm for greatest common divisor. And the same program ran like that. That's an example of a problem that is seemingly simple, but the difference between the obvious solution and some sort of mathy solution made a world of difference in terms of runtime. So some problems just happen to be computationally complex that we might not have realized that would fall into that 1% problem, something like that. Yeah.
Just a quick question. So when you declare like an integer, you have to obviously it can only be an integer, but if you declare a double or a float, can that also be an integer, or does it have to be something like a decimal type?
No, it can. If you have a double or a float and you put a 3 in there, it'll be stored as a 3.0.
Okay.
So you could put an integer in there, but it'll map to a floating point value. If you have an int, you can't put a double in there because usually the warning will be something like possible loss of precision, something like that, because a int does not know how to store decimal point numbers. So it'll truncate, it won't do any rounding, it just cuts the decimal point off. Okay, so Java's high level, strongly typed. It's a compiled language. Now, I'm going to throw something in here that says compiled-ish. From our perspective, it has all of the properties of a compiled language. But one of Java's claim to fame And we did talk about this at least a little bit last semester. Anybody remember what Java's claim to fame is? It's possible we didn't talk about it. I don't always discuss it. So the idea was it's platform independent. Did we talk about that? So it's platform independent, write once, run anywhere. All right, so the idea is back then, and this was usually the Apple people, see, Mac people think they're very, very important. And admittedly, they're more important today than they were back when Java came out in the late 90s, mid 90s, let's say. Back then it was like 0.5% of people were running Apple stuff. Everybody else was running Windows. Now it's like 5% are running Mac stuff. The other 95% are running Windows, something like that. It's still pretty skewed, but back then the idea was, all the new video games are coming out for Windows and I have to wait a year or forever for it to come out for my Mac. So the idea is that Java came out, it was made by Sun Microsystems, which over the time got purchased by Oracle. I probably asked this last year. Does anybody, who has heard of Oracle before? Do you know what they make? Larry Ellison, the CEO of Oracle, is like top 7 richest person on the planet. And you don't know what his company does. Isn't that kind of funny? Anybody in here know what Oracle's product is? They make a database called Oracle. So a database management system called Oracle. It's an enterprise level database. So places like Amazon are probably using Oracle. Their competitor would be like Microsoft SQL Server, IBM DB2. On the free side of things, MySQL. If you've ever done a website-y thing, and MySQL databases are usually a dime a dozen, and they're fine. You just probably don't want MySQL driving Amazon. The number of simultaneous transactions would be too much for it. Yeah, but it is funny that Oracle is arguably the most expensive and highest performance database on the planet, yet people don't know that that's the product that company makes. Isn't that funny? I think they own a couple of like sports stadiums and things like that. It's actually, yeah, is Oracle Arena, is that Heat? Miami? Oh, Oracle, the Warriors are Oracle. Yeah, so they've got like national championships under their belt. We don't even know what they make. It could be like a cereal company, probably owned by General Mills. That's a grocery store joke. If any of you have ever worked at a grocery store and you walk down the cereal aisle trying to decide, what should I buy? Doesn't matter what brand is, like every one of those boxes at some level is owned by General Mills. Every one of them. I don't care what logo is on that box. There's a hierarchy of companies that deal in oats. Something like that. So Java, platform independent, write once, run anywhere. So code compiles to Java bytecode, which is an intermediate low-level language that at runtime converts to native assembly. We probably talked about this last semester in the context of C#, how .NET programs, they compile down to Missile code, Microsoft Intermediate Language, which then runs, gets at the first time you run it, it gets converted into assembly code. But Microsoft will say, our .NET languages are platform independent as well. They'll run on any platform as long as it's Windows. Which is kind of funny, right? It has to support the .NET component architecture. .NET component architecture is only available for Windows, so it's technically platform independent as long as you can run the .NET component architecture, which only runs on Windows. So it's platform independent as long as the platform is Windows. This is the punchline. All right. But ultimately, code runs on the JVM, Java Virtual Machine. All right. And this has all sorts of security benefits by today's standards. So back then we would have said, oh, Java was too slow for some of these things. But today we might say our computers are fast enough that Java's fine. And having your program running inside a virtual machine has a lot of benefits to it. All right. Questions, comments, concerns, bribes? All right, I'll see everybody on Thursday. Make sure if you haven't already done so, you join the Slack channel for 250. We'll make announcements on there. That's cuwcs.slack.com if you haven't created your account. And I'll see you in the front row of chapel tomorrow.